I want you to draw a circle in the middle. We'll see how this goes. And I want you to make a little person here twirling and write E field here. Is that how we define the E field? So a person with arms stretched, twirling around, creates a field of influence around them. If this person is a charge, we call that field electric field. Okay, now I want you to do this. Different things could happen. If I bring a charge in the vicinity of this field, what will happen? It will experience what? A force. And that force will be given by QE vector. And that force, the unit of that force will be Newton. This means the unit of field is newtons per coulomb, right? Going back from here to here. Now I want you to make another box here. What caused this charge to move in the vicinity of the field? Something has to have happened to it to bring it there. Agreed? We call that something work. So the work and energy are related by a formula called the work kinetic energy theorem from Intro 1. Work is equal to kinetic energy or negative potential energy, right? From conservation of energy. The first part of that equation comes from the work kinetic energy theorem, and the second part comes from the conservation of energy. And I also want you to make another box here. And I want you to label it potential. So let me define these words and then I'll come fill these boxes again. Okay. I want you to define first potential. What is potential? There are two main ways we defined potential in Intro 1. One was when we were doing circuits. And number two was when we were talking about the electric fields. The confusion arises because they are both represented with V. So let me try to separate the two out a little bit. So when you talk about circuits, you generally define this potential as electric potential difference. And that is defined as the measure of how much energy is transferred between 2 points in a circuit. And we wrote that as V equals IR, and we called it the Ohm's law, where I is the rate of change of charges. So that basically is not electrostatics. It is when charges are moving. When we think about electric fields, we can define them as two different things. One, I can define it as electric potential. And second, I can define it as electric potential difference. When I define it as electric potential, usually textbooks define it as work per unit charge needed in order to bring the charge from infinity to a point, say R, in the field. Note, unit is volt. Whereas electric potential difference is generally defined as the potential developed while moving a charge from one point to another in the E field. They are technically the same thing. They are not different, except we have defined them, and to add to our confusion, we define them in two different ways. However, if you look at this definition, what it's saying is that if I was to move my charge from point A to point B, the potential that I develop while doing this will be given by VB minus VA equal E dot DL in the field itself. And if I move it to this side, what I'm saying is that my charge was initially at infinity, and then I moved it to, say, point B. At infinity, the potential is 0. So the same equation will become VB equal minus E dot DL from infinity to the point B. So do not get confused between these two things. Or that.